Okay, look up. Key thing today, listen, key thing today is we do introduce some new ideas, and they're not really complicated, but it is the type of idea that sometimes it takes a lot of conversing until your brain says, oh, I get it now. So don't hesitate at all to just ask about anything. I mean, I always say that, but today probably a little more than, actually the next few days, that's going to be the case. So here we go. This is an FRQ, no calculator. It says the graph of f shown above, and I will again remind you, you must read very carefully. This problem involves g and f, and if you don't read carefully, it's super easy to get off track. I've worked with teachers who, when they work a problem like this, will be doing just fine, then suddenly they'll stop remembering that this is the graph of f. They'll start thinking of it as being the graph of g. So just be cautious. So that's the graph of f. It says let g be the function given by this formula. This also causes people some mental anxiety, but it shouldn't. Like if I told you that g of x was equal to 3x squared minus 2x, you wouldn't feel any anxiety at all. So the fact that g of x is defined with an integral shouldn't be any different. An integral is just a mathematical operation, just like anything else. Questions? So don't let the fact that g is this integral bother you at all. It says find g of -1. I would like to see how many people can look at the problem and without any assistance, just raise your hand and tell me. I don't think it's that hard. What should I do if I'm supposed to be finding g of -1? Feel free to talk to each other. Just raise your hand when you're ready to tell me. It's not a trick. I just want to make sure you're thinking with me, not just watching. So hands up. What do we do? Let's go, Jack. So I could do that. I could come up here. I could go to x equal -1. Ticket for Jack. However, flaw in that thinking, somebody raise your hand and tell me the flaw. Point for Andrew. Okay, let's go Daniel.
The graph is for f, not g.
Correct. So this is the graph of f. So I can't just look there. That's not sufficient. How many knew that? 2 points, 3 for Daniel. So hands up again. What should I do? Let's try Jonathan.
I would put -1 in for x on that equation.
So I write the equation they gave me. I write g of -1 equals. Please make sure you are writing g of -1. This particular FRQ is asking you to find 3 separate values. You've got to be clear to the grader which value you're working on. So g of -1 will equal the integral from 0 to -1 of f of t dt. Hands up if you knew that. 2 points, 3 for Jonathan. Question? Carl.
Do you have 0 to -1 as an integral?
Then it would be -1 to 0.
2 points. So it is legal to integrate going from right to left, but I don't really recommend it. It's safer to always go the same direction. It just prevents mistakes. So the next thing you're going to write on your paper is this. G of -1 will equal -1 multiplied by the integral from -1 to 0. If you switch the limits and multiply by -1, the value does not change. And it prevents us from going backwards.
So like if you had 0 to -2, you could times it by -1 and keep the -2. So it just happens to be that the negative ones.
No, really good observation, Carl. Yeah, the negative one here, 3 points for Carl. The negative one here has nothing to do with this negative one. That's what you're referring to, right? Yeah. Anybody else? Awesome. Okay, first big idea of the day. We're looking to find the value of g of negative 1. And according to this equation, if we knew the value of this integral right here, if we knew the value of this integral, we'd have it. We just need the value of that integral. Okay, look, come on, focus. If I were to ask you a completely different question, in fact, I want you to write this down. So on your paper up here at the top, if I said, please give me the formula using an integral for calculating the area that I'm about to shade, need a bigger shading tool. You write that down, please. What would be the formula that uses an integral that would find that shaded area? This is not new. Just write down your answer. Talk to each other if you need to. Just review from Unit 4. Also review from the blue sheet. Remember, I hear Autumn talking. For now, this line that you see, this graph is just f of x. So your answer will be using f of x. There won't be any equation or anything, just the symbol. Who has it? Hands up. Come on. What would be the formula for writing the area of that space? Logan.
The integral from -1 to 0 of fx.
Okay, show me if you have that on your paper. Show me your hand. 2 points, 3 for the question. Please, Prince.
That horizontal line, is it like measuring in like x's or like t's? Because in the equation there, it's f of t.
Gotcha. So you're wondering about the horizontal axis, yes?
Yeah.
Awesome. Hold on. I'm going to give an explanation. If it doesn't help, keep talking. When we look at an integral, remember that really, we've done this a couple of times. The variables you see here are really temporary. Because the way integration works is you would plug in 0 for this, whatever this is. Then you plug in 0.1, 0.2, 0.3, whatever. So it's just a placeholder.
Okay.
So you've seen me, not often, but sometimes I'll even put a z there or a w. Doesn't matter. It's just the horizontal axis. Doesn't care what we call it.
Okay.
Is that fair?
Yeah.
Does that make sense?
Yeah.
Anybody else? Okay. Anyone have questions that this formula would find this pink area? You would need me to give further explanation. Okay, so memorize this phrase then. If you can use an integral to find an area, that means you can also use an area to find the value of an integral. You would need me to repeat it. So look at this problem here. G of -1 is related to the value of this integral. But this integral corresponds to the pink area. And that pink area can be found with non-calculus methods. Because that pink area is a simple triangle that has a base of 1 and a height of 3. So -1 multiplied by 3 halves And I would stop there because I don't have to keep going. So that's the value of g of negative 1. We need me to talk through it again. Uh-huh. If I can get you to help me, it'll stick better. Is that okay? Are you okay with this equation here? Good there? So what I see as I look at the formula, as I ignore the negative 1, I see the integral. I come up to the graph of f, and I note that I am starting at x equal negative 1, right there. I stop at 0, and I'm integrating out. What that means is I'm going to be finding all the values of f between these 2 points. The values of f are literally the height of vertical lines, because that's how our graph works. So that integral is going to find that area. Okay with that? But that area can be found in a completely different way because it's a pure triangle. The height is 3, the base is 1. The area of a triangle is 1/2 the base times the height. So that pink area is 3/2. Hence, the value of g of negative 2 is negative 3/2. I didn't have you talk very much, but did that help? Okay. 3 points. Please.
Why didn't you find the area of the graph of f on the negative?
Oh, gotcha. Hold on. So are you okay that when we integrate, we're taking this x value and we're plugging it into f? So we're finding the value of f at many different coordinates. The values of f, we think of them as being these dots. You okay with that? But they're really the y coordinates, and y coordinates are measured from here. So there's nothing going on down here. Does that help?
Yeah, that does.
3 points. Please.
Why did you have to multiply by the negative 1
To flip it. If you don't remember, it's fine, but tell me if you remember, what is the meaning of dt? It is. It's an infinitesimal distance. It means change in t, and in this case, as Brindley said, we're thinking of the horizontal axis as the t-axis or x. It doesn't really matter. So it's a change in t. If you are integrating from left to right, t is changing in a positive manner. If you integrate from right to left, dt becomes negative. So you can do it going this direction. I just think it tends to introduce error. So I prefer not to. But all that happens is this becomes negative. So this kind of compensates for that when you flip it around and go the other direction. So I don't know if that helped at all. 3 points. Awesome. So g of negative 1 is found on the AP test. That would earn you 1 point. 59 to go for a 4. That's not bad. Only 43 to go for a, no, wait a minute, 48. 47 to go for a 3.
You get a 1 though. That's pretty sad.
Just remember, last year, 76% of those who passed the test got a 4 or a 5.
What is 5?
71 to go for a 5. What's that? Say again. They did. It was that whole COVID thing where, so that helped. The hard part was you had to do it at home, and it was like, you only got 2 questions.
I would
It's
rather-
like you really had to nail those 2 questions.
I want 2 questions. I only want 2 questions.
Well,
So
that's kind of misleading. I didn't mean to mislead you. In a normal year, there are 45 multiple choice questions of the type you've been practicing.
Yeah.
And then there are 6 FRQs, but each FRQ has like part A, B, C, and D.
Yeah.
Last year, no multiple choice. You had 2 FRQs. The first one had like parts A, B, C, D, E, F, G or something. And then the second one was more traditional, like A, B, C, D. So that's what they had. So you didn't have to nail it compared to a
Yeah.
regular year.
Yeah.
So no, they did really well.
That's
The students who,
like every point.
there were a higher number of students who, because of the whole COVID situation, being having to work at home alone, just gave up. Like there were, because 2 years ago I had 91% of the students from my classes pass the test. Last year I believe it was 83, but I feel like that was too bad of a drop off considering the whole COVID thing. And then the best part was that 76% of that 83 got a 4 or 5. So, okay.
I'm not gonna lie, at home was way easier.
Here we go. We need to find g of -1. G prime of -1, sorry. Let me copy this over. Okay, look up. Okay, next task is to find g prime of -1. Listen. Okay, as much as possible, I'm always trying to find ways to help you get through an AP problem without introducing any new ideas. The more often I can have you use the same tool repeatedly in different ways, the easier it is for you. So I'm hoping that several of you, if not all, would be able to say, that doesn't sound like a difficult problem because they gave me a formula for G, and if I had this as my formula for G, I'm pretty sure I would know exactly what to do. So don't do anything, and don't be just like raise your hand if you can tell me what does it appear to you we should do. Like if it feels like you're going to get stuck, don't worry about it. You got to get used to that idea. But if it feels like you're going to get stuck, don't worry about it. Just say, well, this makes sense. I think this is where I should go. So what do we do to find g prime of 1? That's better. Wallace?
I don't know how you do this, but would you somehow like find the prime of f of t? We don't know what f of t is though, so I don't know.
So
That's my thought.
you said exactly what I was hoping you would say. And that's why I gave this hint, was the idea is that if you knew this was the formula for G, Allison, would you have any trouble at all finding G prime of -1? No. Whole class, if you knew this was the formula for G, please raise your hand if you can honestly say you would have no trouble finding G prime of -1. 2 points, 3 for Allison. So all you're missing, look at me, come on. All you're missing is a rule to find the derivative of this right there. You already have rules to find this derivative. That's why you all raised your hand. The only reason Allison's like feeling stuck is because she doesn't quite know, well, how am I supposed to find the derivative of that? Is that fair? Question? Please.
If the integral, or sorry, what's the name of just like the s x0? Is that the
Antiderivative.
antiderivative? If that is, kind of going down a level, can't you just not do that and just say f of t is your g prime?
So what Jonathan's saying is that if g of x were equal to the antiderivative of, we'll say h, to not confuse the two problems, look up, and there were no limits, just a pure antiderivative, then you could say with certainty that g prime of x is simply h of x. Is that what you meant?
Yeah.
Yeah, that's true. However, as soon as they put limits, the same thing will often occur, but it just won't always occur. Is that okay? So you have to be a little more careful. Are you with me? So there's a rule. It's on your rule sheet. It's actually the only rule on that pink sheet you haven't used yet. The rule looks terrible. It's right here. I would not, don't try to memorize all the symbols. Just watch what I do and memorize what I do. It's really a very easy rule to use. So here's what you do. You can't find g prime of 1 yet, because as we've done all year long, we've got to go find the formula for g prime of x first. So we're not going to do this yet. First, we're going to write down that g prime of x, g prime of any x, will equal. Here's how the rule works. Easiest rule you'll ever memorize. You simply take this. We've talked about it. It's called the integrand. Okay? You need me to write down the word?
Wait.
Oh, go ahead.
I was going to ask, is the integrand f of t and dt, or is it just f of t?
So technically speaking, the integrand is just f of t, although on tests sometimes I will tell you that they'll take off points if you don't have that right as well. That's probably what you're remembering. Yeah. The integrand is technically just f of t, but you can't forget the dt. So, good point. Okay, so here's how the rule works. If I'm taking the derivative of an integral, just remember the wording, derivative of an integral. All you have to do is write down the integrand. You don't have to do anything, but just write it down, but plug in the upper limit. So we have f of t, which means we'll have f of x. And then you multiply by the derivative of that upper limit. So you have d over dx of the upper limit. That's the first half of the rule. Question? That's all this says right here. If you're finding the derivative of an integral, go find the integrand. Here it is. Plug into that integrand the upper limit. Then multiply d over dx by the derivative of that upper limit. Question? Edward, please.
So while we have the constant number in the limit spot, it's just going to be 0 every time.
Yep. The second half is what Edward is seeing. That's a name ticket. The second half is what Edward is seeing. That the rule just continues with the lower limit. So you write down, and this part you can do in your head. I'm writing it to be clear. This is going to be minus the integrand with the lower limit plugged in, multiplied by d over dx of that lower limit. And Edward noticed that this is going to be 0 whenever...
So it's just a constant in general, because the dx, the d of a constant over dx is just 0.
So yes, anytime this is a constant, this will be 0. Is that what you meant?
Yeah.
Sorry, I didn't mean to say again, Edward, sorry.
So the whole equation is going to end up being 0.
No, because it's a subtraction.
But wouldn't the
This is 0.
d of -1, isn't that 0?
Oh, the upper limit's not -1. You see your mistake.
Keep going. I think I get it. But
You're okay. Let me show you your error. Actually, hold on. I know what you're saying. I just got to help you see the mistake.
Isn't the derivative of a constant 0?
Here's your error. Actually, let's get everybody back together. Everyone's got to see this mistake so you don't make it. Everyone, look here. Come on. We're trying to find... Edward got a ticket for this. It's a really good question. We're trying to find g prime when x has a value of -1. So he's saying we're going to put a -1 right here. Like, here's my formula for G. So he's saying, well, we need to put a -1 here. Isn't that right? That's incorrect. Who knows why? Hands up. Who knows why that's wrong? It's always been wrong, all year long. Like, you have never done that. Like, if we had a formula like this, it's a really good question. And you wanted to find G prime of -1?
Oh, it's a different.
You don't put a -1 into that. That's finding G of -1. How many knew that? How many saw the mistake? 2 points. You do not, does that make sense?
Yeah.
Does that help? It's good work. Anybody else? Yeah, you must find the derivative first, then you plug in the -1. Are you with me? Okay. This is your formula for G prime of any x. Question? Please.
So when you did minus f0 of b0, is that just because the bottom limit is 0, or is that
Just because the bottom limit is 0. Yeah, the rule specifically says take the integrand, plug in the upper limit, multiply by derivative of the upper limit. And then repeat for the lower limit. Look at me, come on, caution. I've seen people get mixed up because you just did 4 packets, okay, where you're using the fundamental theorem to find the value of integrals. When you're finding the value of an integral, just an integral, you have to go find the antiderivative of f, and then you plug in the limits. That's what you just did for 4 packets. This is different. This is finding the derivative of an integral. Therefore, we don't go find the antiderivative of this, we just use that as is. Otherwise, it looks a lot like the same process. Okay. Questions? Awesome. This is 0. Caution. It's really important that you get this part correct. You can't put a dt because we are finding the derivative of a formula that is defined to have an input variable of x. So it has to be dx. It's always based on the input variable. As I said to Brinley, the t here is really temporary. It's not a variable at all. It's just a placeholder. Okay. Questions? Awesome. So now we have a new formula. We have the formula g prime of x is simply equal to f of x. Questions? So raise your hand, please. Now what do I do if I want to go find g prime of -1? Hands up. There we go. Let's go, Daniel.
Look to the graph.
Yeah, I looked. Sounds like profound wisdom. So g prime of -1 is exactly the same thing as f of -1, which has what value, Daniel? Apparently the board doesn't want it to be 0. Questions? How many knew it? 2 points, 3 for Daniel. Actually, I'm giving Daniel a ticket. Questions?
Daniel took like focus.
The end all. Questions? Eric?
Wouldn't that not really make sense with like Gantt's chart and all that stuff?
Keep talking.
It's like because it's increasing, it has to be positive.
Hold on, take it for Eric. See if you can catch your error. At the beginning of the discussion, I said it's really common in a problem like this to make a certain mistake. You remember what I said? You don't remember, it's fine. We're working with G and F. It's easy to get them mixed up. What you're noticing is that if this, like, how do I say this? the relationship between G and G prime is such that if G is increasing, G prime is always positive. But this isn't G.
That's a, yeah.
Does that make sense?
Yeah.
That's common to do that. True. Souvenir. Okay. Questions? Awesome. We still need to find G double prime of -1. Okay. Again, trying to help you see that you should not be altering your thinking at all as you work through this problem. Yeah, we threw in a new idea that you could find an integral using area. We used a new rule, but otherwise our logic has been the same as it's been for months. Okay? So please raise your hand if you have any ideas to how we might find G double prime of -1. Hands up. You all know how to do it. I don't need to teach you anything new. How do we find G double prime of -1? Let's go Isaac in the back.
You just take the derivative of G prime.
So I have a formula that says G prime of any x is the same thing as f of that same x. And if I use the chain rule and take the derivative of both sides, I'm going to get G double prime of that same x, technically multiplied by d of x over dx. This would become f prime of that same x, multiplied by d of x over dx. You don't need to write these steps. You can do it in your head. Therefore, G double prime of any x is the same thing as f prime of that same x. So show me your hands if you knew that's what I should have done. 2 points, 3 prizes. Question? Now you plug in the value you're searching for, which is -1. So let's make some space here. So we're looking for G double prime at an x value of -1, which is going to be equivalent to whatever the value of f prime is at x equal -1. Okay, I don't need to teach you anything new. You all know well, you all have the tools you need to find this value. Raise your hand if you know how. Hint. It all goes back to remembering what is the meaning of the symbol f prime when x is -1. For hands? Hoping for more. You all learned this months ago. What does the symbol f prime of -1 mean? Once you know what that means, then you'll know how to find f prime of -1. So let's go there.
It represents the tangent slope at that -1.
On the graph of f. So I go to a value of x equal -1 on the graph of f. I need to find the tangent slope at that point. The graph of f is linear at that point, hence you should be able to find the slope. So how many knew I was looking for the slope at that point? 2 points, 3 for Zaren. Please raise your hand when you know the slope at that point. You can talk to each other if you want, just to make sure, but please raise your hand when you know the slope at that point. Don't overthink it. Paul?
Is it 3?
Last time I checked. Over 1, up 3. Somebody got it? 2 points. 2 for Paul. Question? Awesome. All right. Okay. Hint for number 2. Hint for number 2. Just follow the exact same pattern you followed in number 1. You should be fine on finding all the answers to number 2, so I'm going to leave that as practice for homework. One thing that will be different is when you plug in 3, you'll be integrating from 2 to 3, so there will be no need to reverse the limits. So, question. Go to number 3, please. Same idea here. So nothing new to show you there. Go to number 4. Number 4 does have something new, so let's work on that one together a little bit. So if I'm going to go find, let's see, g of -1. So g of -1 will equal the integral from -4 to -1. That's going in a forward direction, left to right, so no need to do anything different, of f. Questions so far? Okay, ouch. Look up. Hey, remember, I think it was David's question or Jonathan, I don't remember which. Remember what integration means. When you integrate, all you're doing is you are taking these values of x, t or whatever, and you're plugging them into this. So we start at x equal -4. We find the value of f at that point. That value is definitely negative. We then multiply by a tiny amount. So we find the area of this blue rectangle, but that area gets computed as a negative number because the value of f is below the x-axis. Wave at me if you need me to go through that again. That means every value of f that we calculate, every value of f here is going to produce a negative number. So it's going to be finding the area that I'm now filling, but it's going to find a negative number for that area. Questions? So I just look at it and say, okay, that's easy. Just divide it into rectangles and triangles. This is 2 by 3. This triangle is 1 by 3. And the whole thing gets counted as a negative. Question. Please.
How, I don't get the negative. How can an area be negative?
No worries. So the area isn't negative. So let me just talk through what's happening again. So when we compute this integral here, we are taking values of f and we're multiplying those values by a small amount. But every value of f from here to here is a negative value. So you're getting some negative number multiplied by a tiny amount. Ignoring the negative, it is the area. So the area is not negative. The computation is negative. Did that help?
Yeah.
Does that answer your question?
Yeah.
Okay, please. 3 points.
I'm just a little confused about the whole rectangle triangle.
Oh, no worries. So, Logan, are you okay that in trying to find the value of that integral, I'm focused on this shape? Good. Are you okay that I know that because every one of these f values is negative, this integral is going to be some negative number? You good with that? Okay. Therefore, all I've got to do is find the area of that space. And the way you can find it using the formula for a trapezoid, if you remember the formula. I'm not really a big fan of, I'm trying to make as few formulas as I can. So what I do instead is I just split it into a space that is made up of a triangle and a rectangle.
So, like when we're doing antiderivatives, and you get like the limits, and plug them in, you'd be like the limit, like f of that one limit subtract like the lower limit, you know? Why do we not do that here?
Oh, take it for that. I think I know your question. If I get it wrong, ask again. At this moment, I'm trying to figure out how to find the value of that integral, right? The way you did it on the gold, pink, yellow, and blue sheets is you said the fundamental theorem tells me that I can go find the antiderivative of this. Got me? So put it equal here. Okay, all eyes on the board. The antiderivative of small f on the AP test is often referred to as capital F. Okay, that is not a mathematical rule. That is simply a tradition that they use on the AP test. So you can't count on that being true, but it's often true. Is everybody with me? So using the fundamental theorem, I would find the antiderivative of small f. That would equal big F. And therefore, instead of integrating small f, I would be evaluating big F. Is that what you were thinking? Awesome. Raise your hand if this makes sense. How many's good to hear? It's no different than what you did on the gold, pink, yellow, and blue. Whenever you found an integral, you had to go find the antiderivative first. It's just the antiderivative of small f is big F. Once you found the antiderivative, you plugged into that antiderivative two values and subtracted. Raise your hand if this makes sense. That's better. 3 points for all. Are we good to hear? Please, Carl.
Sorry, one kind
You're
of
good.
thing like with the negatives. What if your graph, like your area that you're trying to find, was negative and positive? So like if you went from -4 all the way to 2, you have that triangle that's like positive.
Gotcha. Hold that question for just a second, is that okay?
Yeah.
Don't forget though, because I want to come back to it for sure.
Okay.
Is everybody good to hear? Okay, Logan and everyone else. I'll pay everybody. On the, again, buff, yellow, pink, blue packets, this worked. For this problem, it's impossible. Well, impossible is too strong a word. It is possible, it's just not efficient. How many can tell me why I didn't go this route? It's not wrong. It's just not efficient. Why did I not do this? Hands up. Why did I not choose to go find the antiderivative of small f? It's kind of staring at you. Why did I not choose to find the antiderivative of small f? Let's go, Carl.
Because the line changes.
That's one big reason. I don't have a formula for small f.
Yeah.
On all those packets, you always had a formula here for small f. So you could find the antiderivative. Here, no formula, but what I have instead, which is actually easier, I have a graph of f where everything's straight. So I can use that phrase I taught you at the beginning. If I can use an integral to find an area, I can use an area to find an integral. So you now have 4 methods of computing integrals. Calculator, Riemann sum, which is an approximation. Calculator is an approximation too. Antiderivative fundamental theorem, and area. These last 2 methods they're flawless. There's no error. If you're finding the value of the integral perfectly, it's not an approximation. Logan, did that answer your question? Okay, question. Please, Allison.
So the limits for your integral are -4 and -1. Where do you get the -1?
So they gave us a formula here. Same thing again. If what I say doesn't help, tell me to say it differently. Everybody, look. Learn to read this differently than you have typically read this. It'll make a huge difference, I promise. Listen to the way I read it. The value of g at any x can be found by simply integrating f from -4 to that x. So because I'm supposed to be finding the value of g of -1, I want to integrate from -4 to -1. If that helps. 3 points. Question. I told you at the beginning of the year, key to success on the AP test is you learning to be able to speak calculus properly Because if you can talk with me, you'll get a great score on the AP test. You will. Because it shows that you understand the ideas. Just like what I just did there. So, question. Cool. So, we're not doing this. If this were an FRQ, I would stop. I would not go further. You don't need to. Just stop right there. Just don't forget the negative or you lose the point. So, questions? Please.
On this problem and also number 1, what like written work is required to get the points?
Outstanding question. Because the problem doesn't say anything about show computations, justify your answer, that sort of thing, no work is required to be shown. You can literally write down, you can look at it, solve it in your head. I wouldn't recommend it, it's easy to make a mistake. But, so to me, the work I gave, I think, is perfectly appropriate. Like, this is a very safe path. It prevents me from making an error. I don't have to keep computing, but you don't have to. You could just write negative, what is it, 6 plus 3/2. I can't do that in my head. Shoot.
Negative 15 halves.
15 halves, thank you. That's why I don't do it. I stop there. So, 3 for Brindle. To answer your question, John. Okay. Please.
So when it says find the value or state that it does not exist, does state mean that it can be used?
Hold on. Everybody listen to Autumn's question. Look up. Come on. Focus. Outstanding question, really. The reason they're saying, the reason they say find the value or state that it does not exist is they are hinting that they might ask you to find something that cannot be found. Is that okay? I'll show you why they did that on this one. Doesn't mean that it always can't be found. It's just their way of kind of making you think a little harder. So look, if I want to find g prime of -1 now, just like in the first problem, I've got to go find g prime of x. So using the formula again, the way I find the derivative of an integral, because I'm trying to find the derivative of this, is I just take the integrand, plug in the upper limit, multiply by the dDx of the upper limit. Oh, questions for the whole room. How did I know that this should be dx and not dt? What's the indicator? Hands up, come on. You got to get this one right. What's the indication that I should be finding dx, not dt? So Daniel?
Is it no longer an integral, so it doesn't need to be iterated?
2 points, but no, it's okay. 2 points, but no. Let's go Jackson. Jackson, sorry.
The input variable in g prime is x.
Yeah, always look here. You started with this. So my work's a little haphazard today. You started with the formula for g. The input variable of that formula is an x. Therefore, when you go take a derivative, it's got to be dx on the bottom. How many knew it? 2 points, 3 for Jackson. Question? Then it would be subtract the integrand with the lower limit plugged in. The lower limit in this case is -4, multiplied by the ddx of that lower limit. Okay, warning, in many problems, when you compute g prime, it will turn out to equal f. It just doesn't do that all the time. So don't get lazy and just think that that's always the case, because that is not always the case. Please.
How come you don't plug in the upper limit, but you plug in the lower limit? How come you don't plug in -1?
So the difference is that the original formula for g looks like this. The The original formula for G looks like this. So the -4 is a part of the original formula. -1 isn't. -1 is later. So the original formula has an x. So when I go to take the derivative of G, I have to use the part of the G formula. Once I find the derivative of G, then I can plug in any x I want. That's your question. 3 points. Carl.
To have it be not, to have g prime of x not equal f of x, wouldn't you have to have an x in the lower limit as well as the upper limit? Or,
So here's what I've seen over the years. If they give me a formula for G, and the formula for G is an integral, if the upper limit is anything other than x alone, then things change a bit. With me? If the lower limit is anything other than a constant, things change a bit as well. Yeah, that's why I teach you the rule, so you're prepared for whatever they throw at you. That makes sense. Yeah, 3 points. Good questioning today. Anything else? Okay, so we found the formula for g prime of x. Please raise your hand if you can tell me the value for g prime of -1. Hands up. I want to know what is g prime of -1. We found g of -1. What's g prime of -1? Hands. That's better. For a couple more here. Let's go Miles.
Maybe f of -1.
Please raise your hand if you knew what Miles just said. 2 points. And then Miles, what is f of -1? So here's a good example of where you can't stop too soon. You do have to go to here to get the point. How many knew it? 2 points, 3 for Miles. Question? Awesome. I need to get your question, but I want to do this first.
yeah.
Okay, now I need to find g double prime of, because this will answer Autumn's question. G double prime of -1. Please raise your hand. What do I do to find g double prime of -1? Please raise your hand. What do I do to find g double prime of -1? Come on. That's better. Let's go, Tanner.
We find the derivative of g prime of x equals
So I have this formula. G prime of x is equal to f of x. So Tanner, what would g double prime of x equal? Okay, show me your hands if you were able to get to this point on your own. 2 points, 3 for Tanner. Carl, oh, here's,
No,
yeah,
I
here's.
just, yeah,
So now I plug in an x value of -1. Please raise your hand if you can tell me what is f prime when x is equal to -1. Hands up. What is the value of f prime when x is equal to -1? Maybe for a few more. Let's go Zarin.
It doesn't exist
Because?
because it's on a corner, so it's not differentiable.
Perfect. So that's why, Autumn, they have this. Does that answer your question?
Yeah.
Okay. How many knew that? 2 points, 3 for Zarin. Question? Okay, I want to do Carl's question, because it's going to come up, guaranteed. I tried to give you a good explanation for why I can find the value of an integral using areas. I want to give you a shortcut. just to make the test go faster. If they said find G of 2, actually let's go G of 3. That means I will be finding the integral beginning at x equal -4, stopping at x equal 3, and I'm integrating out. Okay, raise your hand if you can honestly say the purple makes complete sense to you so far. Points for the room. We want to talk about it. People that raise their hand. Okay, here's the shortcut. I know that because the graph of f is simply linear segments, I can calculate the value of the integral without any calculus. All you do is start here, draw a vertical line. Because that's x equal -4. Come over here to x equal 3, draw another vertical line. You are integrating f, so just make sure you identify f. Okay, just a shortcut. dt means horizontal axis. So draw that. You have now created 3 distinct spaces. You have to find the area of those spaces. That works every single time without fail. If you're trying to find the value of an integral using area, just draw 4 lines. Left limit, right limit, integrand, horizontal axis, done. Any area that is above the horizontal axis gets counted positively, area below gets counted negatively. Questions? And I simply divide the space into rectangles and triangles. Like that. So this, we already found this one. This was 15 halves, right? So that has to count negatively.
Actually, you need another triangle.
Oh, you're right. Thank you. So that would have been to here. Am I correct so far? Then that triangle is 2 by 1. Half of that is, remember, this gets counted negatively again. Half of that is just 1. Oh, please.
Could you not just look at the graph and say, like, okay, those triangles cancel out with each other, or not cancel out?
Add to make 0.
I meant to say, yeah, they'll add up to 0.
Yeah, they add to 0.
Then does that mean the area for that shape is the same area as the one that we found at the beginning?
The space.
The one that we found in the original problem was like an A.
Total area is just negative.
Well, this is 15 halves.
Yeah, but the other two.
This is 1, this is 1, this is 1. So yes, these are the 2 you're looking at, right, Zarin?
That last triangle.
Those last triangles.
The last triangle, is, yeah, you're right, thank you.
So it's just.
So the answer is exactly the same. Yeah, good eye, didn't see it. Well done. To answer your question, Carl.
Yeah, I got it.
Questions, anyone? Please.
Okay, wait. So I noticed when you're doing like the area, when you show us the first time or whatever, you put like a negative and then like brackets and stuff. Can you explain like the difference between brackets and parentheses?
Oh, no difference.
Okay.
Yeah, it's just tradition.
Okay.
So tradition is to use parentheses first, and then when you feel like you've got to clarify, you use brackets.
Okay.
You've used Microsoft Excel. You've done any programming? No. In programming languages and like Excel, they tend to just stack up the parentheses.
Yeah.
Human beings, it's a little hard to start seeing, which parenthesis goes with which. So the brackets just make it easier to see. Yeah, they don't have any, in that context, no difference in meaning.
Okay.
In this context, when I'm talking about an interval, the bracket and parentheses do have a different meaning. Is that your question? Good job. Good point. Please, Miles. Don't talk, you can't hear. Don't leave, I got to tell you something. Go ahead.
like G double prime that nature like doesn't exist or whatever. You have to say equal doesn't exist.
Oh, thank you. Hey, I'll be a ticket for that one. Yeah, it doesn't equal doesn't exist. You just, G prime of, I didn't do that very well. It'd be better to say G prime of -1 does not exist, like the sentence. Okay, look. Really good discussion today. However, you are not prepared to complete the gold packet. So I strongly recommend you get through problem 6 and then stop, and we'll pick it up again on Tuesday after President's Day.
So we do 1 to 6.
1 to 6. What I
No,
recommend.
cool.
Good work.
Wait, do we have school on Monday?
No school on Monday.
School on Wednesday.
School on Wednesday next week.
Yeah.
No, it's not a holiday.